Now we have another example for the control hazard or instruction hazard. So whenever we see an unconditional branch, there is sure to be some kind of instruction hazard. So let's see why. So whenever there is a branch, we have to see which address we have to jump to. So let's say the branch address, the address to which we have to jump, is computed in the execution stage. So in that case, let's say I2 is the branch instruction. So I1 is executed as usual, F1, D1, E1 and W1. I2 is the branch, F2, D2 and E2 happens. E2 is when the branch address is executed. When the address, the execution phase of this branch occurs, the compiler gets to know that this instruction is a branch instruction and it has to jump. But by that time, by E2, the F3 is done, fetching of the third instruction is done, decoding of the third is done, and also I4, F4 is also done. Fetching of the fourth instruction is also done. But the thing is, by the time the E2 is done, it's an unconditional branch. So 3 and 4 will be skipped and it will go to some IK as it's shown here. So already we have already fetched and decoded the third one and also even fetched the fourth instruction. This much is going to waste just because of this unconditional branch. And we have to again start from the fetch in the 5th clock cycle. You have to again start from the fetch for the kth instruction. So K, we have computed the branch address in the execution phase. No. So that shows we have to jump to the kth instruction. So we'll jump to the kth instruction and we'll do the fetching. From the fetching we have to do again from the 5th clock cycle. So this is here it is very clear that this much portion is getting the fetching and all. The third and fourth instructions that immediately succeeds the branch instruction is getting useless because of the unconditional branch. Now let's see the case in which the branch address is computed in the decode phase. Here it was done in the execute phase, and we can also compute the branch address in the decode phase. So what happens there is the first instruction is as usual happens. Then the second one, it's a branch instruction. After it's fetched and decoded, here the compiler gets to know that it is a branch instruction, and the branch address is also calculated during the decode phase. Now by the time it is decoded, the third instruction is fetched. But we get to know that we have to jump to the kth instruction. It's an unconditional branch. We have to jump to the kth instruction. So from here, from the 4th clock cycle, we have to again fetch this kth instruction and we have to start executing it from the 4th clock cycle. And this fetching of the third instruction, it is going to waste because it is not going to be executed. So as we can see, in almost all the cases, an unconditional branch will result in some pipeline stall, because the I3, even though it is fetched, it cannot be used. And in the case in which branch address is computed during the execute phase, a lot of fetch and decode, all these is going to waste just because there is an unconditional branch.